desperately want you to understand, you don't have to suddenly understand all of physics behind this. You really just have to understand those basic ideas. The problem's not going to go into this huge, detailed physics. No, it's not. That's not the point. But how can I rewrite di dt? I itself is dq dt, so di dt is another level, right? So d squared q dt squared. So that's the voltage drop. So I don't know how many of you guys know the Kirchhoff rules and the voltage drops. All the sum of the voltage drops across all the pieces have to equal the voltage coming from your voltage source, battery, whatever it be.
In a realistic one.
Oh, come on. Then you introduce the ohmic heating and all this other stuff, yeah, right? Remember, in physics, you start with frictionless tables and massless ropes, and you're like, where do I buy that shit? Frictionless table would be horrible. Right. Massless rope just sounds really neat to me. But. Resistor. This is the V equals IR thing. I don't know if you guys know IR, and how can I write that? That would be R dq dt. We normally write that as like a coefficient. And then the capacitance is the nice one for us. Capacitance is going to be, what was it, Jeff? Q over, it's been too long. Oh, just Q over C. So the R is the value of the level of resistance, right? The measurement of resistance. C is the capacitance. It's really the capacity for it to hold something. And then L is the inductance. You gotta love it. C capacitance, R resistor, and of course, inductance is L. You already had I for current, so what do you want? Okay, there's one problem that deals with this where you have to figure out. Let me write it all down. So the total voltage supplied has to equal the sum of all the places where you lose voltage. So you lose a voltage drop. So it'd be this plus this plus this. So you start with your battery gives it voltage, and then you lose. Back to zero. The battery gives it voltage again, lose. Get it all back, lose it. Get it all back, lose it. And that's what makes everything work. Okay, I like it. Of course, it's not really. It's always. Okay, those are the big ones I wanted to talk about from that section. You really just have to get in there and ask questions. You have to start trying those problems out. See how far you can make it. The one that asks about this, there's no solving of these yet, obviously, because, like I said, we haven't officially learned how to solve anything yet. Officially. I showed you a few things, but that was just on the side. All right. I desperately want to sneak some of this stuff in from section 2.1. I have to. And from 180, do you remember doing something like this? You did something like this here. And you would graph this. Now, the first thing you do is you get a function and you try to sketch its derivative. When you're learning derivatives, you actually draw the derivative before you figure out how to calculate the derivative. When you learn integration, you sketch the antiderivative before you learn how to do the antiderivative. I don't know if you guys remember doing this. And normally your brain hurts when you're trying to shift gears. But this, what does this tell me? No constants here. Oh, okay. One thing is that it doesn't depend on y. And why did I do that? Because I wanted to get us back to 180. One of the big changes with Jiffy Q is this can be a function of x or y, or a combination of both, right? And in 180, you wouldn't know what the hell to do with that, for the most part. So I wanted to bring us back to 180 a bit to show you what happens with us in 285. What is x, though? I mean, we just talked about it a second ago. This is f of xy, right? Where y just doesn't show up. And what does that tell you? I mean, what is this? What does this represent? The slope. So the slope everywhere is equal to the value of x there. So could you sketch, well, first off, can you just draw x? Now, what would the function look like that follows this rule? Well, this tells me the slope at all the points, right? So what's the slope right at here, that value of x? What's the slope got to be? What's x here? 0. Which tells me what about the actual y function? Good, that it's got a horizontal tangent line, right? Where is it, though?
What's the whole x around the whole plane?
That's the whole point of when you take, what is the,
You need the C.
what is y? Yeah, you need the c, x squared plus c. Because all the information this gives me is that it is flat. It could be here, it could be there, and of course it's going to be parabolic, right? Negative slope that's getting less and less negative to 0, and then positive slope that's getting more and more positive, that's a parabola. Where's it going to be, though? Well, this by itself doesn't tell me. That's that extra parameter c that somebody has to give me more information. Is everybody, old shit, that's old news. So what we're going to do now is, like I introduced a minute ago, we're going to have this, more generally. And how do I really start to analyze this? Well, this tells me the slope at every point, because the input for this is a point, x, y. Right? You can kind of look at it in that way. So, I mean, one way to look at this is there's a y I want to get, and that's kind of like the thrust of a lot of what we do. So 2-1 continues the frustration a bit. It says, we're not going to solve it yet, but we're going to show you what the answers would look like. Right? So, I know it's low, but that means that I now look at this in a slightly different way. I say for some input points, I can figure out what the slope would be at that point. And how have we chosen to represent that? By drawing a little, what's called a lineal element. For a point x, y, we draw a lineal element with a slope equal to f of x, y. So if you know vector fields, you should probably be able to tell the difference between a true vector field and this. They're not really the same. It isn't a vector I'm drawing, it's a representation of the slope. And the best way to represent a slope is a little line. Okay, I want to get to the point where I can show you the kick-ass thing, because doing this by hand sucks so bad. So I think I signed one thing where there's a special thing you can do to make it by hand easier, and that's the only thing we're going to make you do, trying to do this by hand. Well, let me show you just the idea. If I had this, so I just want to get you the idea. I'm not going to do enough to really fully get this down. So, I mean, your inputs are going to be x, y now, and your outputs are going to be slopes. So for the point 0, 0, the slope is 0. So that doesn't mean that, now, so forget vector fields, whatever. At 0, 0, the slope is 0, so my little lineal element would be like that. So any curve that goes through 0, 0 has to do that. So once I get this all plotted, oh shit, I can then be given an initial condition and just follow the arrows and draw what the hell it would look like. That's kind of the idea. What about 1, 0, 1, 0? There it is, Jeff. 1, 0 and 0, 1, they would both be 1, right? So then you kind of, one way I decided to do this is it would be parallel to that. So you can see why this would get really, really bogged down trying to do this whole thing by hand, right? So it's parallel to that little element, this 1, and here, same thing. Do you see the idea? And you can see how it gets really, what's the difference between 1 and 1.1 if that happens? What about, just to do another one, negative 1, negative 1? Negative 2, yeah. So then here, it would be parallel to, I always do, so it would be down 2 over 1. So it would be parallel to this but at -1, -1. So like, let me see if I can do it. I'll screw it. Doesn't have to be perfect, Jeff. So obviously, as you move, it's going to get more and more negative here. As you move out here, it's going to get more and more negative, and here it's going to move more and more positive. Yes, sir.
So the difference between this and a vector field is these don't have magnitudes?
Yeah.
Yes. That's the most evident, immediate difference. Real quick, back here, it would get a little more interesting because what's going to happen all along this line here, this is the line what? Y equals -x. And if y equals -x, so all along there is going to have a slope of 0. Yes?
So it's like a slope field, a vector field, but not exactly like a vector field because there's no magnitude.
Okay, yes, that's the main difference. This is purely us deciding to use little lineal elements. These are not vectors. These are little elements that represent the direction something would be moving in. That's very different from what a vector field actually does, to be really honest. Some of them sort of sound like that, but not really. Yes?
When you draw this graphically, does the arrowhead really matter which direction it's going?
Yes.
Yes.
Well,
Wouldn't it go
For
both
x,
directions?
for the 0, it doesn't.
because dy dx, you got to be careful. Like here, I mean, it's a negative slope, but I kind of see what you mean.
Couldn't it be pointing up just as easily?
What did I draw like that for? It's negative, so it's got to be this,
Yeah.
because I'm so close to it. So like that. It's definitely got to capture that. But you're right. We normally choose to put it that way, sort of, for the most part, just because we normally think of dx as that direction.
Right,
But if I'm drawing this, if I start here, I can go, well, it looks like it's going to go like that, and then it's going to go back. It's like it's telling me where it would have come from then. So in essence, you could put the arrowhead the other way, and it means the same thing.
Part of picking your units.
Because positive slope means it's going down as you read that way. I mean, right? That's what positive slope means. As you go that way, it's going down. So that's kind of like changing the arrowhead. Real quick, I got to show this is. So now that I've shown you how disgusting this could be, I want to show you two things, and then I'll let you guys out of here. Did you turn off? No, you're there. You're just waiting for something to happen. Computer. What happened? Oh, you turned all the way off, did you? You little lazy. What time is it? Oh, I got 5 minutes.
No.
I'll just take pictures.
I changed my mind. I want to show you 3 things.
Oh, yeah.
Oh shit, that's gonna take a while. Alright. Okay, let's see if I can do this without typing my password so you guys can all see it. Found the right thing. Just get me to my mail. Whoa. Where's mine? There I am. I don't know if you guys know about Geogebra. I can send this out to all you guys, but there's the x plus y. Let me take that green away. But if you go to Geogebra, one thing it does is differential a direction field plotter. See up in the corner, I've got f prime defined. So that's the x plus y. Let's see, does it match with, yeah, see here? 0, 0, 0, 0. Notice how they don't put an arrow in this. So that's kind of like what you're saying. And the nice thing is you can change the length of those. And you can change the density. Wow. Increase the resolution a bit. And then you can say, okay, what if there's a point, what if there's an initial point at a certain place? What would the solution look like? This is what I was talking about. Those lineal elements that represent the slope, they tell you what direction that if it goes through this point, it's going in this direction. Then you can see how it starts to turn here, flattens out here, It's got to follow those. So in that sense, it feels like a vector field because it's all about like the wind is a vector field, all that kind of shit. But still, it's not quite a vector field at all. It has nothing to do with speed in which it's doing this or whatever. And you can go up here and just play around with this shit, and you can get some really nifty things. Yeah, I like this one. Look at that niftiness there. Woo! Look what happens right here. Pop. Why does that happen? Why is the result? Why is the solution constant? Y equals 1. If you're born on the y equals 1 line, can you ever get off of it? Because your dy dx is going to be 0 everywhere, right? So therefore, if you're born here, you stay here. And if you're not born there, you can never get there. It actually is asymptotic back here. Just can't really see it. I think it can, oh well, I'm not going to play too much with this. You can go there and play with that sucker. I wanted to get up to phase portraits because this thing is really cool. Phase portraits deal with autonomous DEs, which is the correct word for when there's no x dependence. There's only y dependence. If there's no x dependence on your slope, that means as I move in this direction, it's always going to look the same up and down. So like, I made this just, y times y minus 1. Do you see how for any given x, it looks exactly the same? Of course it does, because it doesn't give a shit about x, does it? The slope is only related to the y position. So as I move along the x line and look up and down, it looks exactly like it just did. So what we do in this case is we create what's called a phase portrait, where we only just do one line, because it's going to be repeated forever in both directions, so why waste my time? And then I worry about, is it going up or down, or is it flat? And of course, where's it going to be flat? 1 and 0, which, not surprisingly, we call those critical points, because it's where the slope is 0. And that's going to be related to these places. Here's 1 and 0. And what's going to do in those 3 regions, do you see that? There's 3 regions created. So this picture is just so awesome. Do you see that? This is very interesting. Woo. Is it, Jeff? I don't know. This is really, really, I wish I would have had this when I learned this. It's so awesome. We'll obviously get a lot more into that next time. I think I'm out of time. Sorry. All right. But yeah, you can go there. There's another website called plot.ninja that a student of mine made a while back.
Oh, it made it?
Yes. And it does 3-dimensional graphs much better than almost anything. Oh, yeah. So you're good? Okay. This next time.
Which there's the website.
Website. But as long as you can get caught up with everything. Yeah. Sure.
Oh, and also, do you have an extra set of stuff?
With me, no.
I like it. I mean,
You have a website?
Yes.
Can I get that website?
Yes. Do me a favor, Jeff. If you'll email me, I can send you like all the emails I sent to everybody.
Okay.
But I mean, it's basically just like that's my website. Equal Jeff Wallen. Yeah. And you get everything right there.
Hey Jeff, you're saying you can get the homework out of it?
Yeah, if you come to my office, I can. Actually, I'll tell you what'll make it really quick for me is I have like an extra one of these that I can let you borrow for a little bit. What's your name?
Alberta?
Rena?
Yeah.
Did you take roll?
Make sure. I don't take roll. Pass book. So you can borrow this for a bit until you get your book.
Thank you.
Can you, before the professor,
What's up?
should I go to your office then?
Yeah, let's go. Let's get out of